This is the second slide set in for week 5, and it deals with trying to understand ecosystems and their complexity by using a network view. So ecosystems are complex, we all know that, but what it means is that there's multiple independent interacting components, lots of organisms, lots of little places to hide, all that sort of stuff. And when you have a lot of small pieces all moving around, obeying their own rules, it can lead to what's called emergent behavior. And that's a behavior at a larger scale that's qualitatively different than you would expect just from, or be able to predict just from the individual actors. So an example of that is just a bee colony. The social activity of a bee colony leads to a whole different structure than you'd expect if you just studied individual bees or ants. And because of this, because individual actors are doing things and there can be a lot of possible outcomes, this leads to a high degree of uncertainty. And we're going to talk about that in week 7. So the idea that if ecosystems are complex, how can we try to manage those? And one of the points is that we're going to have to manage them by starting out thinking that they're not so simple. So if we think they're just simple mechanistic machines that we push a lever and something happens, that's probably not going to go very well. So for example, do we think of the ecosystem as a homogeneous area where everything obeys all the same rules and does the same thing? Or is there a lot of spatial and temporal connectivity that's important in our analysis? Do we focus on competition, just who wins under very set conditions? Or do we focus on cooperation and symbiosis between large numbers of organisms that work well together to create the environment and create the overall outcome? And the answer is yes, this is what we do. We're going to try to have to think about cooperation. Do we think about just stability and resistance to change? No, we're going to have to be dealing with resilience, the ability to accept stress and still maintain a system integrity. And instead of equilibrium coming to a set point, we're going to be looking at pulsing and constantly changing dynamics, but yet that's the nature of the system. And very similar, are we looking for a steady state outcome where inputs always equal the outcome, and then that's what we're looking for? We're looking again for something that's much more dynamic, and we have to look at it over larger time scales or larger spaces to even all that out. So the approach to management needs to change, and we can do that. And this is being done by looking at and embracing some of the complexity that's in these systems. So talking about this, all the reading, the reading in the book, the reading in the Wikipedia or Encyclopedia Earth, all of these are going along with these themes of the course. And in this case, one of the themes we can look back at is we were looking for patterns and taking a precautionary approach. So if you're looking for, if a complex ecosystem is very uncertain, you're going to have to look for patterns. You're not going to have a cause and effect relationship all the time. And also, another underlying theme of this course, we need to keep the goals in mind. So for example, there's a video about bees and how important they are. And do we want just food, or do we want a healthy ecosystem that supports food production? So do we want to have farms that are so efficient that and large that they truck bees in and that's actually commercially feasible? Or do we want to have systems that are more organic and complex? And in this case, that's where we get down to this question about resilience. If you do everything, if you put all your eggs in one basket, so to speak, and something goes wrong, you're in big trouble. And that's again one of the values of looking at these complex systems, complex ecosystems, trying to manage them for resilience. So I'm going to do 2 examples very quickly here on what we know about these complex systems and ecosystems, and then how we can, what that means for management. And so first, let's just talk about succession. So primary succession is going from bare ground all the way to some large trees in a forest. That's a terrestrial system. And this can be studied by, in this case, a glacier is retreating. The glacier is retreating. So 100 years ago, the glacier was way over on the right. 80 years ago, it was up right here where these, if you can read this, a Sitka spruce were started to be in there, and essentially, and all the way over to the left. So when the glacier just retreats, there's bare rock, and it takes a while for the little plants and lichens and fungi to establish themselves. They break down some of the rock, they trap dust, they make sort of a soil, and then plants start going in. Now, secondary succession is when we've already built up some soil, and there's a good amount of organic and nutrient resources, and really just the top vegetation gets cleared off by, say, a storm or a fire, and it just grows back. And secondary succession, the way we manage for secondary succession in our society, this is really what agriculture is. We have soil as a resource, and we clear it off, and we plant certain things back in, and then when they come back in, they're growing up. If we were to let that go, it would eventually turn into a natural community, trees would come in, that sort of thing. But we just keep interrupting it always at that state. But it depends on having that soil as a resource. So if you're managing ecosystem for this, and we're going to be talking about that next week when we talk about mosaics of the forest and response, this is really one example of managing a complex system to go with the complexity of the system and the natural processes. Now, another one that we have a good video on, and that there's a lot in the news, is restoring top predators to Yellowstone National Park. And there's, in the D2L side, I've posted a video, but really the short story of this long process was the wolves were extirpated from this whole region of the American West, but in places like Yellowstone that were natural reserves, the elk population expanded. They stood around all day in the stream areas. They ate up any little tree shoots that might come up, and eventually have these very sort of streams just running through meadows with no trees around them, very unnatural sort of thing. And so the wolves, one of the things the wolves do in a natural system is they keep the elk on the move. The elk travel around in little herds. A few of them get eaten. But remember, like in the videos from week 1 where we had these ungulates moving around from area to area, and they move in a herd and they eat the forage, and then they move to the next place. That's really what the wolves, that's one of the major impacts that the wolves have on the elk population. It's not direct consumption. It's not like the amount of elk that are eaten by wolves. It's how the wolves change the elk's behavior. So this is a very sort of complex interaction. Now, wolf reintroduction also had many other benefits to the ecosystem, and they discuss a little bit of that in the video, and there's some web pages that support that. We know that wolf reintroduction is a very hot topic, and if you want to make some comments, you can go into the discussion for this week, where hot topic comments are welcome. Just please be considerate of each other. So that's an example. This is discussed in the other material, but I wanted to point this out as looking at this and describing it as a bunch of complex interactions really takes some fairly sophisticated tools to be able to do that and to make a coherent presentation. And so the next steps are do the reading. The chapter 7 on networks has a lot of information in there, in particular on the the response of networks to stress and how it shares the stress, the sort of compensation response. And then do their reading and watch the videos. There's one on bees and how bees are being insulted by so many different factors that it's like multiple factor bee death, and again what their value is to agriculture and to humans, and then also the one on Yellowstone. So I think that'll be a good start.